3 to 2 prong adapters are often considered ineffective and dangerous for several reasons. Firstly, they often lack proper grounding. Even when screwed to the faceplate, these adapters frequently fail to establish a proper ground path, primarily because the electrical boxes themselves are unattached or ungrounded. Secondly, they give a false sense of security. Users might incorrectly believe their devices are properly grounded, leading to complacency and potential accidents. Thirdly, they present an increased risk of shock. If a device connects to a faulty ground wire or an ungrounded outlet through the adapter, it can actually increase the risk of electric shock. In some limited situations, 3 to 2 prong adapters might seem applicable, such as for temporary use. This includes short-term or infrequent use of low-power devices in isolated locations. Additionally, there is the use case of legacy equipment. In rare cases, older appliances might not require grounding or may have damaged ground terminals. However, even in these specific cases, it is crucial to ensure that the adapter is properly installed and the ground terminal is connected to a reliable ground path, which is often not the case. Overall, it is generally recommended to avoid using these adapters altogether. A safer and more reliable solution involves replacing non-grounding outlets with ground fault circuit interrupter outlets of 3-prong outlets with a proper ground wire connected back to the electrical panel. Grounding is a critical safety feature in electrical systems. It provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices, such as circuit breakers or fuses, to quickly interrupt the circuit in the event of a ground fault. This helps to prevent electrical shock hazards and reduce the risk of fire. When an appliance or electrical device has a 3-prong plug, the third prong is connected to the device's metal chassis or enclosure. This connection is designed to provide a path for fault current to flow back to the electrical panel in the event of a short circuit or installation failure within the device. Without a proper ground connection, the metal chassis of the device could become energized, posing a significant shock hazard to anyone who touches it. Ground fault circuit interrupters are designed to detect even small amounts of current leakage to ground and quickly interrupt the circuit, typically within milliseconds. This rapid interruption can prevent serious electrical shock injuries. GFCIs are particularly important in areas where water is present, such as bathrooms, kitchens, and outdoor locations. The use of 3 to 2 prong adapters bypasses the intended safety features of the grounding system. When an adapter is used in an ungrounded outlet, the third prong of the appliance is not connected to a grounded conductor, rendering the grounding system ineffective. This can create a dangerous situation where the metal chassis of the appliance can become energized without tripping a circuit breaker. The small metal tab or screw on the 3 to 2 prong adapter is intended to be connected to the grounded metal faceplate screw of the outlet. However, in many older homes, the electrical boxes are not grounded, meaning that even if the adapter is properly connected to the faceplate screw, there is still no effective ground path. Even if the electrical box is grounded, the connection between the faceplate screw and the box may not be reliable due to corrosion, loose connections, or paint. This can further compromise the effectiveness of the adapter's grounding connection. Many people are unaware of the importance of grounding and the dangers of using 3 to 2 prong adapters in ungrounded outlets. They may assume that because the appliance is working, it is safe to use. However, the lack of a proper ground connection can create a hidden hazard that could lead to serious injury or even death. Replacing 2-prong outlets with ground fault circuit interrupter outlets is a relatively simple and cost-effective way to improve electrical safety in older homes. GFCIs can be installed in place of existing 2-prong outlets without requiring any new wiring. They provide a level of protection against electrical shock that is far superior to using 3 to 2 prong adapters. Replacing 2-prong outlets with grounded 3-prong outlets is another option, but it typically requires running a new ground wire from the outlet box back to the electrical panel. This can be a more complex and expensive project, but it provides the most complete and reliable form of grounding protection. When considering electrical safety, it is always best to consult with a qualified electrician. An electrician can assess your home's electrical system and recommend the best solutions for improving safety and ensuring that your electrical system meets current codes and standards. Additionally, it is crucial to remember that electrical work can be dangerous and should only be performed by qualified individuals. Improperly installed wiring can create a fire hazard or increase the risk of electric shock. Therefore, it is always best to hire a licensed electrician to perform any electrical work in your home. Many older homes have electrical systems that are not up to current standards. This can include outdated wiring, undersized electrical panels, and a lack of ground fault circuit interrupter protection. If you live in an older home, it is a good idea to have your electrical system inspected by a qualified electrician to identify any potential safety hazards and recommend necessary upgrades. When it comes to electrical safety, it is always better to err on the side of caution. Taking the time to ensure that your electrical system is properly grounded and protected can help to prevent serious injuries and protect your home from fire. Additionally, it is important to educate yourself and your family about electrical safety and to follow safe practices when using electrical appliances and devices. This includes avoiding the use of 3 to 2 prong adapters, never overloading electrical circuits, and always unplugging appliances before cleaning or repairing them. Ultimately, the goal is to create a safe electrical environment in your home where you can use electricity with confidence and peace of mind. By understanding the importance of grounding, avoiding the use of unsafe adapters, and consulting with qualified electricians, you can help to achieve this goal. Consider the implications of an ungrounded appliance in a kitchen. Imagine a toaster with a faulty heating element. The metal casing could become energized, and if someone touches the toaster while also touching a grounded object like a metal sink, they could receive a severe electric shock. The same scenario could play out with a power drill in a workshop or a lamp in a living room. The potential for harm is present whenever an appliance with a metal casing is not properly grounded. In addition to the risk of electric shock, ungrounded electrical systems can also increase the risk of fire. When a ground fault occurs in an ungrounded system, the fault current may not be high enough to trip a circuit breaker or fuse. This could allow the fault current to flow undetected for an extended period, generating heat and potentially igniting nearby flammable materials. Furthermore, ungrounded electrical systems are more susceptible to voltage surges, which can damage sensitive electronic equipment. Voltage surges can occur due to lightning strikes, power grid switching, or other electrical disturbances. A properly grounded system provides a path for these surges to dissipate harmlessly to ground, protecting electronic devices from damage. It is essential to understand that grounding is not the same as insulation. Insulation is designed to prevent current from flowing where it is not intended, such as from a wire to a metal enclosure. Grounding, on the other hand, is designed to provide a safe path for fault current to flow back to the source in the event of an insulation failure. Both insulation and grounding are important safety features that work together to protect people and property from electrical hazards. Grounding also plays a critical role in minimizing electromagnetic interference, or EMI. EMI is unwanted electrical noise that can disrupt the operation of electronic devices. A properly grounded system can help to reduce EMI by providing a low impedance path for noise currents to flow back to the source. This is particularly important in sensitive electronic environments such as hospitals, laboratories, and data centers. The National Electrical Code, or NEC, provides detailed requirements for grounding electrical systems. These requirements are designed to ensure that electrical systems are installed and maintained in a safe and effective manner. The NEC covers a wide range of grounding topics, including the types of grounding electrodes that are permitted, the sizing of grounding conductors, and the methods for bonding metal enclosures and equipment. The NEC also requires that all electrical equipment be listed and labeled by a recognized testing laboratory such as UL or ETL. This listing ensures that the equipment has been tested and meets certain safety standards. When installing or modifying electrical systems, it is essential to follow the requirements of the NEC and to use only listed and labeled equipment. Failure to do so can create a safety hazard and may violate local electrical codes. Regular inspections and testing of electrical systems are also important to ensure that they are functioning properly and that all grounding connections are intact. Grounding electrodes such as ground rods and ground plates should be inspected periodically for corrosion and damage. Grounding conductors should also be checked for proper connections and to ensure that they are not damaged or corroded. Additionally, ground fault circuit interrupters should be tested monthly to verify that they are functioning properly. This can be done using the test button on the GFCI receptacle. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. In addition to the NEC, many local jurisdictions have their own electrical codes and regulations. These codes may be more stringent than the NEC and may address specific local conditions or concerns. It is important to be familiar with the local electrical codes in your area and to ensure that all electrical work complies with these codes. The cost of grounding an electrical system can vary depending on the size and complexity of the system. However, the cost of grounding is typically a small fraction of the overall cost of the electrical system. The benefits of grounding, in terms of safety and protection, far outweigh the cost. In conclusion, grounding is an essential safety feature of electrical systems. It provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices to quickly interrupt the circuit in the event of a ground fault. This helps to prevent electrical shock hazards, reduce the risk of fire, and protect electronic equipment from damage. 3 to 2 prong adapters should be avoided, and non-grounding outlets should be replaced with ground fault circuit interrupter outlets or 3 prong outlets with a proper ground wire. Regular inspections and testing of electrical systems are also important to ensure that they are functioning properly and that all grounding connections are intact. When it comes to electrical safety, it is always best to consult with a qualified electrician and to follow the requirements of the NEC and local electrical codes.